This is Pre-Calc section 7.2 video number 4. This is the first one on hyperbolas. The hyperbola is a set of all points in a plane such that the absolute value of the difference of the distances from two fixed points is constant. Remember, the ellipse definition was such that the absolute value of the sum of the distances remains constant. So the two fixed points are called foci. Now, one major difference between the hyperbola and the ellipse is that the foci are located outside. Remember, with the ellipse, the foci were on the major axis and they were inside. The foci here are outside. Now, the hyperbola is just the blue curve I have right here. All this other stuff, these lines through the middle here, those are called asymptotes. This little dotted box is going to help us graph the hyperbola, but the only thing that is the hyperbola are those little curves right there. This right here is the formula for a horizontal hyperbola with center 0, 0. This is a horizontal hyperbola because the x squared is positive. It has nothing to do with the size of the denominators. You determined for the ellipse if it was horizontal or vertical based on the size of the denominators. Notice we don't have any idea about the size of these denominators right here because they're a's and b's. But we do know this is a horizontal hyperbola because the x squared came first here and it's positive. The reason I say usually comes first is I have seen books where they get kind of tricky and they give you this, negative y squared over b squared plus x squared over a squared equals 1. And you might think, oh, this is vertical because the y squared is first. It is not, because this could get rewritten so that the x squared is in front and it's positive. Your book does not do that to you, but I just point that out for other courses you may take. So this is a horizontal hyperbola. We are going to name just about all the same stuff we named for the ellipse. And it's over here. Same picture over here. Here's our formula right there. Here's another major difference. To find our a squared, b squared, c squared, we use the formula a squared plus b squared equals c squared. For the ellipse, it was a minus in between there. For the hyperbola, it is plus. And the way I've always remembered it is it's opposite of this sign. Since the sign for hyperbola is minus, I know my formula for finding a, b, and c is plus. In the ellipse, when this was a positive, we subtracted a squared from b squared or vice versa. Our center is still 0, 0, same center formation. The horizontal axis is called the transverse axis. That's just a fancy name for major axis. Why is the horizontal axis the major axis? Because this is a horizontal hyperbola. And why is this a horizontal hyperbola? Because x squared came first. So you are going to find your foci and vertices by doing something to the horizontal component of your center. So you're going to add and subtract c onto that. That's how we get this for the foci. They're always on the transverse axis, which is the major axis. Your vertices, you're going to add and subtract a onto that part of the center. Why a? Because it is a horizontal hyperbola. The foci and the vertices are always on the major axis, which they are now calling transverse axis. Now here's something new. There are things called asymptotes that are these lines that go right through the center. And those lines help us draw the curve. It's like I tell you, it's like Jello mold that this is going to approximate itself to those asymptotes. And the asymptote formula is just y plus or minus b over ax, where b is the vertical distance from the center and a is the horizontal, just like we called a and b the horizontal and vertical all along. So let's look at an example and see what's similar and what is not. So here we go with the center being 0, 0. A is still underneath the x part. The square root of 9 is 3. Square root of 16 is 4. To find c, though, we're going to do a squared plus b squared equals c squared. So 3 squared is 9. B squared is 16, add that up is 25. The square root of 25 is 5. And right now I'm going to go to the graph. Center 0, 0. A is 3. 3 in either direction here. B is 4. It is a horizontal hyperbola because the x squared came first. Don't look at the size of this and think it's vertical. It is a horizontal hyperbola. And I know to find my foci, because it is a horizontal hyperbola, the c value is getting put onto the x part of the center, so the foci are plus or minus 5, 0. Your vertices, because it is a horizontal, are going to be tacked on here. And it's 3 not the 4, it is 3 because we're talking about it being horizontal. That is your horizontal component. So this will be plus or minus 3, 0. So let's put those on the graph. A foci of positive 5 is right here. A foci of negative 5, or a focus of negative 5 is right here. Vertices, we already have them on there, 3 and 3. Now, I'm going to get to the asymptotes in a second here, but this is where you end up using this little box. And the box is just a tool to help you get the graph right. So you draw a box that goes through those points right there, not through the foci, but through your vertices up here and your y-intercepts there, and that makes a box. And you draw diagonals. It's a horrible diagonal. You draw diagonals through the box that goes through the center, and those diagonals are your asymptotes. Now your asymptotes are y equals plus or minus b, which is 4, over a, which is 3x. That's the equation of this red line. Now, it's a lousy drawing, but we can verify that that really is a slope of 4/3 up 1, 2, 3, 4 over 1, 2, 3. Now, some people teach this without drawing the box. I think the box just makes it easier for you to get your lines drawn in there. And of course, it's just 4/3 x. You can think about it as plus 0 because the y-intercept of these lines is 0 because our center is at the origin. From there, we can draw our hyperbola. And the hyperbola, it is a horizontal hyperbola. So they're drawn just like this. And you come right in here and you let your curve get approximated by the asymptote to touch that vertex right there. And I'll try to draw this one over here and run along there. So the black curve is the only thing that is your hyperbola. The other things, the blue and the red, were just tools to help us draw. Notice where the foci are. They are outside. They are not inside this box. Your domain is your left to right. So this coming in from the left is negative infinity, going up to this vertex point, which is negative 3, union with over here, starting at 3, going out to infinity. Because this is a horizontal hyperbola, your range, which deals with the y values, is just the infinities. So lots of different things to name, but we had some similarities. We found our center the same way we did for the ellipse. We found A and B the same way we did for the ellipse. You found C with a little different formula. You added these values rather than subtracted them. The foci and the vertices were found in the similar manner in terms of as soon as you decided it was a horizontal hyperbola, you were tacking C for foci and A for vertices onto the X part of the center. This asymptote is different, and of course you can tell domain and range looking at the graph. Vertical hyperbola with center 0, 0. This is considered vertical because the y-squared is positive, and here we are, it's coming first also. It has nothing to do with the size of the denominators. We just went over the fact that to find c, we'll end up doing a squared plus b squared equals c squared. Of course, this still has a center of 0, 0 because we're still talking about this hyperbola being centered at the origin. The vertical axis is the transverse axis, or what we were calling major axis. So this is a vertical hyperbola. The foci are on the transverse axis, just like the vertices are on the transverse axis. Remember, transverse axis is just a fancy way to say major axis. Your asymptotes are still plus or minus b over a. And the asymptote and the curve is just the blue. The box and the lines are just tools to help us draw. So take a look at an example. As soon as I see y squared being positive in first, I know this is a vertical hyperbola. My center is 0, 0. And this is where you got to be careful. A is underneath the x, so A is 4 this time. B is underneath the y, so this is 2. To find c, we will do a squared plus b squared equals c squared. So that's 4 squared is 16, 2 squared is 4, so we're looking at c squared equals 20. To undo this, we take the square root and clean that up, so c will be 2 radical 5. So let's get the a and the b on the graph. There's our center. Go over 4 in the right direction, 4 to the left, go up 2, go down 2, and that is going to help me get this box drawn. So I just draw the box the best I can with this little tool. Oops. And then my lines go from corner to corner through the center, and that's going to be my format for drawing my curve. It is a vertical hyperbola, so I know it's coming right along the asymptote, touching the vertice right there. Here we go. Same curve right there. So I've done most of this work just from the graph, knowing what A and B are. The foci, because this is a vertical hyperbola, I know I need to tack my C value onto the Y part of the center. So the foci are 0, plus or minus 2 radical 5. Because it is a vertical hyperbola, the B value, because that's the vertical component, is going on to the Y part of my center. So the vertices are 0, plus or minus 2. I can verify that from the graph. There's my box point right there, 0, 2, 0, negative 2. The asymptotes will be y equals plus or minus b over a, 2 over 4, which reduces to a half x. And I can verify that with my graph here, up 1, 2, to the right 1, 2, 3, 4. That's a slope of 2 over 4, which is a half. Take a look at your picture. Your domain is left to right. Your domain, because this is a vertical hyperbola, your domain is just the infinities. The range requires a little bit of thinking there. The range from bottom to top, I came in from negative infinity, and for this curve got as high as negative 2, and then it started again up here at 2, going to infinity.